Hi, this is Jeff Spence, your Math 135 instructor for the Community College of Denver, and this is a video going over some expected value examples, some problems that we see in 6.1. So expected value is an application, a very useful application of discrete probability distributions. And discrete probability distributions are just when we look at a discrete outcome, x, so discrete is something that's countable, and its associated probability. Now, in 6.1, remember that these discrete probability distributions, the probability of each outcome has to be between 0 and 1, and the sum of the probabilities always has to add to 1. So we're going to do some expected values that apply certain situations, and we're going to have to build up the table of the outcomes and the probabilities in order to answer this. Because the expected value is actually just the mean of a discrete probability distribution. And the mean is this formula here, where you take the sum of each outcome times its probability. So we've done this before. You did this in the classwork earlier where you had a table of outcomes and their associated probabilities. You multiplied each outcome times its probability, and then you added them all up. So it's a pretty simple formula once you get the hang of it, but the hard part about an expected value problem is that you have to put in the outcomes and the probabilities based on the situation and the problem. So that's why we're doing this video. Let's take a look at an example. So in the game of roulette, so roulette is where there's a ball, there's a spinner, and a ball lands on a various number in the spinner. Okay, so the thing spins, and then eventually the ball lands on one of these 38 numbers. So there's a spinner with 38 numbers, of which 2 are green, 18 are red, and 18 are black. So you can, in roulette, you can actually go there and place a bet on black. So you decide to place a $10 bet on black, which means I'm hoping that it lands on one of these 18 black numbers out of the 38 numbers. So if you place a bet on 10 and the ball lands on a black number, you win 10. So you get $10. So they give you your 10 back plus 10 more. And then if the ball lands on a green or a red number, you lose your $10. So what is expected value for a $10 bet on black? Well, if you're going to bet on black, you're either going to win or you're going to lose. All right. So when we say the expected value for a $10 bet, we're really just talking about a dollar amount. Okay. And so the top one, I'm going to assume that I win. So if I win, I get $10. That's what that outcome is worth. That's the value of it to me. So what would be the probability of winning? Well, remember, there are 18 black numbers of 38 numbers, and we're hoping that it lands on 18, one of those 18 black numbers. So there are 18 that are winners out of 38. That's the probability, which as a decimal, give me a second here. It's not a perfect decimal, but it's 4737. I'll round that to 4 decimals. All right, and then the other option is that we can lose our $10. If it lands on a green or a red number, then we lose our $10. So I represent that with a negative 10. And the probability that we lose is actually there's 20 numbers, 18 red and 2 green out of 38 in which we can lose. The probability of that should be 0.5263 if I round to 4 decimals. Notice that the probability of these two outcomes add to 1. Either I win on the top or I lose. So these are the outcomes monetarily, and here are the probabilities associated with them. So once we have these outcomes and their probability, then we just do the formula. We multiply 10 times this probability and then add negative 10 times this probability. Now I'm just going to show this with the fractions. So I'm going to say I'm going to do 10 times 18 over 38 plus negative 10 times 20 over 38. And I'm going to show you how to type that in the calculator. Give me 1 second here. Okay, so to do fractions is pretty simple. I'm going to do 10 times parenthesis 18 divided by 38. And then I'm going to add that to negative 10. If I lose $10, there's a 20 divided by 38 chance that I'm going to lose $10. And I press enter. And notice that, remember, this represents money. So I'm going to say my expected value, plug that back in, is negative 53 cents. So 0.53, and that represents a dollar amount. So what this means is I would expect to lose 53 cents or $0.53 per game. Now, can you lose 53 cents in one game? No. Remember, the expected value is an average, and an average in probability of a probability distribution is the long-term average. So this idea is that if you bet black and you bet a $10 bet on black over and over and over again, you're going to continue. Eventually, you're going to lose 53 cents per game. Sometimes you'll win, sometimes you'll lose, but in the long run, you're going to lose. And each casino game is set up that way so that the odds of winning and losing, or the payouts, are set up so that you would lose in the long run if you kept playing the game. Of course, you can get lucky in the short run, and that's why they say at a casino, if you ever get ahead, you should walk away, because eventually, if you keep playing, the odds are set up for you to lose. So let's look at another example here. Okay, so it says, suppose you buy a $5 ticket in a raffle. There were 4,000 tickets sold, and there is one grand prize of 10,000, 4 second prizes of 500, and 10 third prizes of 100. What is the expected value for your ticket? Well, remember, the value here is just money, so not necessarily win, but the value is either I pay $5 and I win a bunch of money, or I lose my $5. Okay, so let's go from winning the grand prize all the way down to losing. So if you win $10,000, let's happen to say that they pick your one ticket and you win the $10,000. So they'll give you $10,000, but you already paid $5. So this means that you would win. Your actual winnings would be 9,995. 10,000 minus 5. And the probability of that happening, remember, we sell 4,000 tickets and only one of them is the grand prize. So there is a 1 out of 4,000 chance that you're going to win the grand prize. Next, remember, we only have one ticket, so there's only a 1 out of 4,000 chance. Now, there are 4 second prizes of 500. So if one of my tickets wins the second prize, then I win 500 minus 5 because I've already paid 5, so I would win $495. Well, what's the probability that I'm going to get the second prize? Remember, they give out 4 second prizes, so there's a 4 out of 4,000 chance that they'll pick my one ticket for the second prize. Then, if I go on, there's 10 third prizes. So, if you win third prize, you win $100. So if you win $100, or sorry, if you get $100, you'll win $95 because you've already paid 5. And there are 10 of those prizes out of 4,000. Then, if you don't win either of the grand, second prize, or third prize, you'll lose your $5. And what's the probability of that happening? Well, there are 14 winning ways. There are 14 different ways that you can win one grand prize 15 different ways. There are 15 different ways you could win one grand prize, 4 second places, and 10 third places. So that adds up to 15 different ways you could win. So 4,000 minus 15 is the number of ways that you could lose. That's 3,985 different ways we can lose. So 3,985 out of 4,000 is the number of ways that we can lose, or the probability, that we can lose. So then once we have this set up, we take each outcome and multiply it by its probability. So we're just doing 9,995 times 1 divided by 4,000 plus 495 times 4 divided by 4,000 plus 95 times 10 divided by 4,000 plus -5 times 3,985 divided by 4,000. So remember, I did each outcome times its probability. I'm going to type that in. So let me pause this. Okay, so I did the first number times the first fraction, 9,995 times 1 divided by 4,000, plus 495 times 4 divided by 4,000. So that's that probability, plus 95 times the probability of 10 divided by 4,000, plus -5 times the probability of losing, which is 3985 divided by 4,000. So if we play this game, if we did this raffle many times, like if you did this like once a week or something, and you kept playing over and over again, in the long run, you would lose $1.75 per raffle. All right. So if you ever win that grand prize, never play the raffle again because you'll always be ahead. But this is the expected value in the long run. So per raffle. You don't have many raffles, but basically raffles are set up for you to lose. They don't give away all the money, so they're going to keep some of the money. You're going to lose money in the long run if you play the raffle. So just remember, whenever they ask for what the expected value is, remember that there's certain outcomes based on the situation. A lot of times it's win or lose, or in life insurance it's live or die, or there's various outcomes. And then once you have the outcomes, you need to find the probability of each outcome, which is also based on the wording of the problem. And then take each outcome, multiply by its probability, add them up, and get the expected value. So good luck. Hopefully that helps. We'll see you next time.